In here, we will solve a problem where we need to find the distinct ways to climb to the top stair. So at each, we can only climb one or two steps. So when we are at stairs number 2, then we can climb one step, and then reach to our stair number 2. Or we can climb 2 steps right away and we can climb it. So in total, we have 2 distinct ways. So when we're in stair number 3, then we have 1 step. We can climb by 1 step, or we can climb by 1 step and then 2 steps, and then or we can climb by 2 steps and 1 step. So in total, we have 3 distinct ways to climb to there. This is a typical dynamic programming problem. So in dynamic programming problem, the most of the work is done trying to figure out the right recurrence relation. And once we figure that out, it's like the coding part is just straightforward. So let's just start figuring that out. So for our objective function, what is the question is asking from us? We're trying to find how many ways we can climb to the top. So we are trying to figure out the distinct ways to reach to the top stair. And let's define our base case. So our base case, let's say when we are at stair number 1, how many ways we can get to there? We have 1 way. And when we're at stairs number 2, how many ways we can get to there? Distinct ways. We have 2 distinct ways. And our recurrence relation. So how do we figure that out? Let's say that you are at the n top stairs. How many ways there are to get to there? You can climb from the previous 1 step below, or you can climb from previous 2 steps below. So let's translate into the formula. So this is our recurrence relation. Like I was saying, we are on the top of the stair. To get to there, we can climb from the previous 1 step down, or we can climb from the previous 2 steps down, as in this problem it's stating. And since we are relying for the previous steps, this is a order of execution is a bottom-up approach where we are building from our sub-problems, and our answer is f of n. So let's translate that into code. So let's create our array. Array will hold those stairs in it with its distinct ways, and we need to define our base case. So there's 1 way, there's 2 ways, and let's define our, so we are starting from step number 3. Since we covered for the 1 and 2, we are running until the top stairs, and we are just putting our recurrence relation. And in the end, our answer is this one right here. So and another thing we need to take into account that if there is just 1 stair, if n is just 1, we need to just return 1 right away. The reason why we're doing it is because we are defining so we have we will open up, let's say it's like we will have array size 2 and we are trying to access index 2 which is out of bound. So let's run our code. Let's submit it. So for time complexity, it is O of n, where n is all numbers, stairs, and space complexity is also O of n because we are holding all those distinct ways, and yeah, and so we can actually make this space complexity better to make it constant. So all we need to do is just translate, like get rid of the array and translate this into integer variables. So let's actually optimize that. So like I was saying, let's just remove this and we will create variables. So we will optimize it from O of n to O of 1 constant time for space complexity. So for previous steps, we have one way. Previous two, we have this one. And what we are going to do in here is we'll calculate for the current how many ways we had it. So for that one, we'll rely on the previous steps. And then for previous one step will be the previous two, because we will just reassign it. And for previous two, it's going to be the current one. Then in the end, this will be our answer. So let's run our code. Let's submit it. Now we optimized our code from O of n to O of 1 for space complexity.